especially like a manufacturing perspective, you might only have a certain number of tools at your disposal that you need to design for. And so sheet metal is very common. I'm sure most of you are familiar with at least what sheet metal is. It comes in a lot of different forms, different materials, and it's used a lot wherever you care about lightweight but still strong structures. So like the chassis, the outer part of the car that you see, that's made out of sheet metal. A lot of products that you use probably have some sheet metal parts to them. And one of the reasons why it's very commonly used is because in addition to its like material properties, which are great, you also have the ability to work with it fairly easily because you're able to do things with it, like fold it, that allow you to create things without having to go through, for example, like a whole machining cycle or die casting. And instead, with a simpler set of tools, you can put together a complex object as long as you designed it well. So this box here, this is an example of a sheet metal part. You can see that it's entirely a thin-walled, uniform thickness type of shape, where there's a better picture of it later on here. You can imagine that it came out of a single sheet of metal that was cut out into this shape. So if you've seen something like this in math before, where you can take a cube and you can unfold it into this kind of cross-shaped shape, what people will do is they'll maybe laser cut or water jet this shape out of a larger sheet of metal, and then they can simply fold each of the squares in until you get this shape. And for the rest of the parts that aren't connected, but you still need to join together, you could maybe like weld that, raise it, solder it, depending on like the scale and the material. So for our last week together, we'll just go through how to use this set of tools, since it's there and it may be something you might find yourself using as you go into working on projects in real life. So to start off, I'll kind of walk you through making this box. And for this week's challenges, they are fairly straightforward. If you've done like the previous challenges, you probably have a good basis to make this fairly quickly. And so I'll probably end up showing you one way to do both of these. And the focus for this class will be not so much figuring out how to do it, but to get some practice with using the tools, making something yourself, trying your own things with CAD with the opportunity to ask questions. So I'll start out with the box, and a simple way to do that is we can take a standard cube, and what you'll see here is at the far right of your Onshape, toolbar here, you'll see you have these tools. And the first thing on the list is called sheet metal model. And the way that Onshape handles sheet metal models is it kind of treats sheet metal parts as a different class of an object compared to the things that we've been doing before. So you want to click this just to tell Onshape that you want to start a sheet metal model. And once you click on that, it brings up this window. The tool is open, selected, and you have a few options. I'll use convert. And we'll just go through one by one through each of these parameters and see what happens. So I want to make a box. A cube is the shape of the box that I want. So I'll start by converting this part, right? I only have one part and it was that cube. The moment I click that, what it does is it goes over all the surfaces that that part has. and it converts them into sheet metal basically by taking like the offset surface and thickening it. So you can see kind of this faint outline of what I have is kind of what my end result will be. I'll have 6 sheets of square, perfectly cut out sheet metal. And so that's a good start, but it's not exactly what I want. I do kind of want this to fold together from a single bigger sheet of metal. So let's see what happens. It gives me the next option is faces to exclude. That's pretty straightforward. Maybe I don't want to include all of them. Maybe I want an open top for my box. So I can click on one of the faces and you can see it disappears. So now I can kind of see the inside too, where I have these 5 squares of a certain thickness. And they're all kind of disconnected here. So the last of these 3, edges and cylinders to bend. This simply allows you to click on an edge of your part. So the original part, the cube, is no longer visible, but you can still kind of select the edges that the part had. It'll come up in orange. And as you click on these, you can see it starts to join them together. And I clicked on all 4 of these and there's a problem. Onshape doesn't like that. And that's because I've connected all 4 of these together. So now they form like a closed loop. There's no way that I could have made that just by bending a single flat piece of sheet metal because it has a loop in it and the sheet metal didn't have a loop to begin with. So it kind of considers that for you. It prevents you from doing things that perhaps would lead to a design that's not realistic. So I just have one more edge to connect. That's the bottom face. I'll just pick one like that. And I'm pretty happy with that. Just from this preview, this kind of translucent preview, it looks right to me. It seems like this is something that I could fold together if I had the right tools and I had this cut out. There are a few other options here. I'll leave these mostly for you to try for yourself if you have the need. You can see the default thickness in this case was like a 16th inch. So that is a standard sheet metal gauge. You might go for something different, but that's probably the thing that you'd be most likely to change. The other thing is the bend radius, which kind of depends on the material as well. Some metals are easier to bend like sharply, or some metals you aren't able to make really shallow bends because the metal tends to just spring back if you don't bend it a certain amount. And I'll go into that a bit more, but first let's see what happens. I accept the thing. You can see now the part transformed from a cube into this sheet metal model. So I no longer have that cube that I drew. I just have this sheet metal model. And what I'll do now, for now, I'll just say finish sheet metal model. And that just tells Onshape that I'm done. So having done that, here we go. This is my finished model. It looks just like the box that I just showed you. Not too much exceptionally difficult there. And so next question might be, okay, so I designed this box, and the reason I designed it this way to be more realistic is because I want to make this in real life. So how would I transmit this from my computer to a machine that would be able to create this, right? And so in this right tab here, on the day that we looked on variables and configurations, one of the tabs here is sheet metal table and flat view. So if you open this up, just by clicking on it, you can close it by clicking on it again. You can see that by picking one of the sheet metal models that you've made, I only have one, which is this one. It gives you a preview of the model. So this does look like what this model would look like if I were to unfold it and make it lie flat. So this is great, but this still doesn't get me to my laser cutter or whatever I'm using. What I can do now is simply right click on the model from this side window. And when I do that, I have the option to either create a drawing or flat pattern or export as a DXF or drawing. So it really depends on which one. Most likely, if you're using a machine, you'll probably want a DXF. And you can see just like exporting other things, like exporting parts as STLs, Onshape has a similar way to do that. Demo box. There are a few options. Most of these probably don't worry about unless you're actually making it, in which case you might ask the person who's running your machine. And you can save this file as a DXF. Seems like I have a default tool to open DXFs. I'm not sure if that's from one of my other CAD programs or just a default viewer of sorts, but if you really can't find a way to, like, I guess mine is from SolidWorks, so you might not have that tool, but this is what a DXF file looks like. It's basically just a very simple file where, hopefully you can see this window, by the way. It says eDrawings Pro, but essentially it converts that model into just lines, and these are completely geometrically defined and can be used by a machine. If you want to view DXFs and you don't have a tool, there's plenty of converters online or that allow you to view DXFs. But for the most part, if you're in a place where you need to worry about that, you probably have the tools available to you. So that's the first part of what I'll talk about. I'll pause here to take any questions that you might have. Let me know if I went too fast on anything or you want to see something again, just because that was the pretty important part of using the sheet metal tools. All right, so that's pretty cool. How would I make something like this in real life once I've laser cut out this flat shape? One of the most common tools for working with sheet metal might be something called a sheet metal brake. So if you ever have like a school machine shop or something, it's very likely they'll have one of these. Maybe a bit difficult to tell how exactly it works, but you can find videos of it online. You essentially slip the sheet of metal into a machine where it allows you to create a fold or a bend in the sheet metal at a certain location at a certain angle. So you can imagine putting something like this into one of those machines, bending it right at these lines, and it may not be as easy in real life because the sheet metal tends to get in the way of the machine once you fold it so that it's three-dimensional, but everything's possible if you're willing to try hard enough. So with that, there's a couple more tools that you might find interesting. Each of these you should try for yourself just to get a better feel for it. Because like I said last week, at a certain point, you learn CAD better by just trying things yourself, like doing things until you need a new tool and then trying to learn how to use that new tool more so than people telling you that all these tools exist. But just because like an explanation is always helpful, I'll start out with the flange tool. So that one, you'll notice that I'm not in my sheet metal model anymore. I clicked finish sheet metal model. So I can't actually select anything anymore because I'm not in a sheet metal model. So flange doesn't like that. It wants the sheet metal model for me to find edges or faces, so it doesn't work. So I'll roll back to before I finish the sheet metal model. Right now it's still open. I go back to my flange tool. And now I can select edges. And what a flange is basically like a flat, thin part that comes out the side of another part, right? something like this. So I might flip it around. I'm essentially extending this piece of sheet metal along this edge. I'm allowed to specify something like a bend angle, so I can make this steeper or shallower in terms of how sharply to bend it. And so you can also work with this. You can imagine that I might start with a square and then just add flanges, and that's another way that I could have created this box. Distance is also an option, so whoops, there we go, distance, can make it longer. There's a few other tools that you might use if you're working on something a bit more involved, like maybe trying to make tabs for fitting on panels onto like a robot frame. But for now, that's a flange. That's another way that you can model things. Instead of creating the 3D part and then converting that into sheet metal, you can start kind of in the sheet metal world and add sheet metal related features. So that was flange. Another one is hem. So this one you've probably seen in real life before. I'll quickly show what it does. Just like flange, you select an edge, and what it does is it kind of bends back the sheet metal and presses it flat against where it was coming from. So I have a few options: straight, rolled, teardrop. And I can specify the length as before. You can see what this does is it kind of closes off the sheet metal end. So now when I look into it, I see a bend rather than the end of the sheet metal. And there's a lot of reasons this might be desirable. One is just the end of the sheet metal is probably sharp. It might have just been like a solid finish or whatever. So it's in a lot of cases you might want this finished exterior to be this bend. Another place you might see it, I think, a lot of soda cans at the rim here. It may or may not be present, but you'll see that in most products you have like the sharp edges hidden away from the user. So another tool on the list is called tab. This is something that you might use, like I mentioned earlier, when you're trying to create, for example, a panel that you need to attach to something else. So you can't just send a bolt through your sheet metal part in all cases. You might need to kind of extend the area of the sheet metal just so you have a bit more surface to play with. In this case, you would need to, I believe, draw a sketch, but I guess I can show that. But that's the tab feature. You can see there's a bunch of other ones here, which you can try it for yourself. For the sheet metal, you probably won't have much of a reason to try them unless you're actually making a product. So this class is more just an introduction to let you know that these tools exist, so that in the future, if you ever find yourself needing to make something that can be done with sheet metal, that you know that these tools exist, more so than like contriving an example where you need to use all of these things. But it's pretty much the box. I'll pause again for questions and I'll go into kind of the second shape. All right. The next thing I'll show is just the second part. Let's see. So this one, again, there's a lot of ways to approach it, and it's actually based on a shape that we've seen before in the previous classes. In fact, I think 2 classes ago, I asked you to try to do this using surface tools. And so now we're going to see another way that we can make like a thin-walled structure that has this general shape to it. So I'll start off with the same approach that I did for the box, where I create the solid version of the shape that I want. So this is one way that I could do that. I'm just preparing myself for a loft between perpendicular planes where these sketches are kind of meeting together. And now that I have this solid shape, I can go back and start a sheet metal model like I did before. Again, I'm still using the convert feature, convert option. I can click on the part. It takes all the faces and it kind of thickens them out independently. I can choose to exclude faces, which I will. And for the bends, you just want to pick the regions between these separated parts and they'll join together. I'll show you what happens if I change the bend radius. If I make it bigger, you can see kind of the bend gets shallower. The radius of curvature becomes larger. And you can imagine that if I make it really large, like this, for some sheet metal, depending on the material properties, it might not like a bend that's this shallow. It might just like spring back into shape because it's still elastic. So in reality, it depends kind of how you're going about it. And that behavior might also depend more on like the angle that you're bending it. For example, like this angle of this line relative to this line and the thickness of the material. In any case, I'd selected way too many lines. That's all I need. And with that, I've put together a very simple way to create a shape that we did before in the past. And you might have noticed it was kind of hard to get these faces like perpendicular and square and have these surfaces be continuous, but with this, it's quite easy. And so with that, I'll kind of invite you to try these out if you haven't been following along. Maybe even if you have, try it again on your own, just to make sure you know how to do it. And for most of the independent time, I would say try to make something interesting. Just do something that you would want to make, be it with sheet metal tools, with the surfacing or the planes, or some of the things that we've used in the past, like the surfaces, the variables. I encourage you to push yourself to try to use things you're not that comfortable with, because that's like one of the best ways to learn. One thing that I'll say, I know some of you attempted the regular polyhedra. So one interesting thing to try is to kind of turn this into a sheet metal box. I did kind of try this before the class, but it turns out to be a bit harder because Onshape doesn't like when you try to connect certain faces together. Things that seem like they should be able to work don't necessarily work like that. So it's always a challenge. But I invite you to try things. And with that, I'll leave you to be for a few minutes. In the interim, I might go back and demonstrate the way that I approach some of the previous models. I know from like the homework submissions, maybe not everyone was able to see how all of these models were made. Trying to open my old tab. So if you're curious, just stick around. I'll keep it quiet. But I think from class 6, not everyone. And like to no fault, I know there usually been 3 challenges and you only need to do 2, but towards the end of the class, I'll just go around as we usually do, have everyone share what they've been working on. And with that, we'll wrap it up and finish off a pretty good class. And so for the curious, I might just walk through the banana since that wasn't a very popular submission from that week.
I need help.
Sure. Do you have a question?
Can you just demonstrate how to do the loft again?
Are you talking about this one?
Yeah.
Yeah, sure. I'll just. So we have here, I guess, I'll start from making the sketches since that's pretty important. For this model, what you kind of want is for the end of the banana to kind of transition the curvature from the sweep to a finish, right? So I'll start off just by creating the second profile for the loft, the first one being the end of the sweep. So the way to do that is just by creating a plane using our standard plane offset tool. Set a distance, make sure it's pointing the right way, so outwards. With that, I create a sketch. And remember, one thing you can do if your plane happens to be not aligned with one of the coordinate planes is you can right click on it and say view normal to, or if you're in your sketch, view normal to sketch plane. So that kind of moves your camera into place. With a sketch, my objective here is kind of to get this circle to be centered in this hexagon. And right now there's no way for me to really do that just because the hexagon is not part of my sketch and it's not even in the same plane as my sketch. So how to get around this? I use my project tool, which is the one over here, and it allows me to bring things that are not in my sketch into my sketch. So when I use the project tool, you can see I can select the midpoint of this top of the hexagon, and I can click kind of the tip of this arc. And with those selected, I have enough information to center my circle. So I can make the circle vertical with this midpoint and horizontal with this midpoint. All I have left then is to dimension that circle. And with that, the sketch is fully dimensioned, and I have my two loft profiles. Now for the loft, it's a lot like the kayak that I think most of you did last week, where you start with your profiles, and this time there isn't any guide curve that I have, but I do know that I want the transition from the sweep to the loft to be smooth and continuous, differentiable. So I just use the match tangent, which means that between the curvature of the part that I'm lofting to or from and the start of the loft, I want those to have the same tangent. If you try that and when you're trying things on your own, you don't like that, I mean, try playing with the other options. They may be what you want. This one is match curvature. It's a bit subtle. It's hard to tell what's happening. So you'll often want to kind of work with kind of what you know about the geometry. In my case, what I kind of want is match tangent. And with that, the loft will hopefully just resolve. If not, feel free to ask another question. Bring that up again. Loft has a lot of options. Like as we talked about, there's like a lot of these tools have surface options as well. I have all these extra options that I could tick the box for. But most of these you'll probably know when you need to use it, or you'll find out that you need to use it when you need to use it. So don't worry too much about seeing all these things. So that's that. This may not really be how bananas look, I suppose, but it's a convenient way to end the model. The great thing is it can always change. I can change what it happens to look like. So it does have a tendency to go whenever there's a lot of cases when you're dimensioning things where there are actually like two possible solutions, like we just saw. What you can usually do is just get rid of the constraint and manually kind of move it over to closer to your solution. And once you try again, it'll usually work. So hopefully that just updates the model without nothing breaks, everything's good. Let's see. I think another popular one was, or I guess unpopular one, may have been the spider, which I think might be worth showing again. At least the exterior parts. Although it is also, I'll start on the spider and partway through, I'll start asking people to share what they have, kind of last parting models.
I have to go.
All right, well, good having you in the class. Good luck in your future CAD endeavors.
Thank you.
All right, in a couple minutes, I'll start checking in. I'll put this on hold for now, but I do want to kind of check with another run for the last time. I guess as usual. All right, can we start with Alex Song? Would you mind sharing if you have anything? All right, nice. Yeah. First time doing sheet metal stuff is it's a pretty different way of thinking about things. So it's good to get some practice. Although you might not have an occasion to use it. So it depends on what you want to do, right? Next, how about Alex Wu?
Oh, can you see this?
Yeah, I see it. Yeah, I see you added
Okay,
like
so
a
this
lid.
is my first trash can. This is my other thing, which is a failure of some sort. And this is my banana. Because when I did your kind of way, to me, it looked so I decided to use a mirror.
Yeah, that's definitely a valid way to go about it. I'm glad you tried something different with the sheet metal too. And yeah, just keep up the CAD. Next, how about Donna? Yeah, I see you're starting up your sheet metal model. And so just as we went through, you can do similar stuff. I'm sure you have it all under control. So if you have any specific questions, feel free to ask. All right, how about Luke? Yeah, I see you got the cover, looks pretty good. And the same thing I said before, just keep working at it and you'll improve. I guess get familiar is a better word since All right. How about Selena? Oh, nice. I see you actually went back to the octahedron. So yeah, looks like you connected things together, which is more success than I can claim for the dodecahedron. So good job on that one. And last, do you have any last words for us, Thomas?
No.
Understandable. All right, I'll resume going through the spider. And if you have any questions about anything CAD related from any of the classes, you have the rest of the class to do so. I think I did sort of show what I did do with the spider during the actual class itself. And so as the class comes to an end, I'll just leave you with one more thing, which is where you can go from here to continue improving in CAD. Main thing, of course, would just be to practice. And how can you do that? In this class, we went over like SolidWorks Model Mania. These are a pretty great resource since all these past years of models are available as drawings from this website. And like this person who made this like blog post put together like a collection of all the drawings and the solutions in SolidWorks, which should be pretty applicable just as you work through them. One thing that I enjoyed doing was just looking at objects from my day-to-day life and seeing if I could make them myself in CAD. Things like a shoe, which might seem pretty unconventional from the tools that we have access to, are actually fairly approachable once you try applying your surfacing knowledge to them. Another thing would be maybe if you're really interested, look into other CAD programs. I know some of you had some experience before in other ones. I know, like, I remember someone showed like a, maybe not in this class, but I believe someone showed me like a Tinkercad model that they had made before doing a CAD class, which was pretty great. One thing that I'd recommend is like Autodesk Fusion. There's an education license, which you can get as a student, I believe, and there's a free version as well. Fusion is rather, yeah, you can see there's like a personal free version as well as a education version, which you might have to look into your school for. But if you can get it, Fusion's a good thing to learn just because it's used much more, it is perhaps more used than Onshape. There are also like a lot of different philosophical choices in Fusion that are different from Onshape. And so as you start to learn different CAD environments, you'll get a better feel for adjusting to any CAD environment. So I have a recommendation for where to go. Just try to model a lot of things, try to use new software, and just keep learning. So with that, that's the end of the class. And the end of the whole class, as a matter of fact, since this is week 8. So goodbye, everyone.
Bye.
Goodbye. Hope you had fun.
Eugene, I'm here. I just want to stop the recording first. Give me 1 second. Yeah, let me just know why I cannot stop the recording. Recording.